Hi everyone, welcome back to my channel. In last class we have seen about capacitor filter and inductor filter. Now we will be seeing about choke filter. The third one is choke or pie filter. This is called as pie because it look like a pie shape. So capacitor, inductor and capacitor. So if you see, this is like a pie shape, that's why it is set as pie filter. This side you will give pulsating DC as input, and here you will get a pure DC as output, C1 C2. Okay, so as simple as that. Just looking at the circuit you can tell charging and discharging of capacitor and inductor and how you will get an output. See, when first signal is given, and first this part 0 to A to B, B to C, C to D. Okay, when 0 to A is given, C1 will start charging. When next A to B discharge part, that is A to B is given, 0 to A. Okay, now when signal A to B is given, what happens is that this C2 will start discharging, because the C1 now has to accept A to B. First it accepted 0A, so it started charging, and now it has to accept A to B, so it will discharge 0A signal. So that discharging will be carried out in this direction. Now this L will start charging. Okay, now next B to C, this signal, when this signal is given, what happens is that C1 will start charging, because for A to B this is already discharged the signal, so there will be no signal or no charge at C1. So next it will accept BC, so C1 charge. When this is charging, what happens to the L? It has to accept the next signal, so this L will discharge. Where will this discharged signal go? It will go to capacitor C2. So capacitor C2 will charge. Now C to D, when C to D signal is given, C1 will discharge. So when this is discharging, that L inductor has to take, so it will charge. When this L charges, it next it has to accept this L's charge, so now the C2 will discharge. I'll explain in just one sentence. Like, this is the input signal. When 0 to A signal is applied, this capacitor will start charging. When next signal A to B is applied, this C1 will discharge, and that discharged signal will be charged by L, so L starts charging. So now B to C, when B to C is given, the C1 will start charging, this will start discharging. That discharging signal has to be accepted by C2, so this will start charging. So when C to D, C1 discharge, L charge, C2 discharge, and this process will continue. First it will charge, for next it will discharge, and this will charge, and for the third signal this will charge, this will discharge, and this will charge. So this process of charge, discharge will continuously takes place. Okay, so I'll explain with the graph. So this is the input signal. This is the C1 output. This is L output. and this is C2's output. Okay, so I am making this dotted lines so that it will be easier for understanding purpose. Okay, so when 0 to A signal is applied, okay, so when 0 to A is applied, C1 will start charging. C1 will charge. So next, when A to B is applied, C1 will discharge. But discharging, the capacitor will discharge at the same time period. But since it is eliminating the unwanted AC signal, it will not take the entire path. It will take the half path because unwanted AC is eliminated. So again charge, again discharge, charge, discharge, charge, discharge. So this is how the output of the capacitor will be. Next, how the inductor works. Starting when the capacitor is charging, L will not be operated because there is no operation for L and C2, so you will not get any output here. Next, when C1 discharges, L charges. So when C1 is discharging only, L will start to charge. So when C1 charges, L will discharge, L will discharge. So next is when C1 charges, sorry, when C1 discharges, L will charge. So it will be like this. Now output of C2 for first signal and second signal, there is no output for C2. Okay, so it will start its action only for the signal B to C. So for that signal, where it is operating is in this case from B to C, this C2 will come into charging. So C2 will charge, discharge, charge, discharge, charge, discharge. So if you see, the AC signal is now obtained as pure DC signal. Not pure, but still repeatedly following this process, you will get a pure DC signal. So that's the operation of choke filter. One thing you have to understand, capacitor will charge, L will discharge, then again capacitor will charge. So this process will repeat, charge, discharge, charge. So again next signal will come, so this will discharge, then charge, then discharge, then again next signal, charge, discharge, charge. So that's how the process will start. So that's the operation of choke filter. Next is LC filter. So LC means inductor and capacitor. So this is load, C and L. So this is also the same process. First, when you get an input signal 0 to A, B, C and D, okay, when 0 to A is applied, first inductor will start charging. When for 0 to A, IL will charge. There is no operation for C. So for next signal for A to B, so this inductor has to accept the next signal A to B. So what it will do is it will discharge the previous signal. So L will now discharge the OA signal. This will, so when this L is discharging, this C will accept that. So now C will charge. Okay, for AB. Then for BC signal, now L will charge, C will discharge. For CD signal, L will discharge and C will charge, and this process will continue. Okay, So similarly I'll draw the graph. This is the AC not AC, pulsated AC voltage and time. So this is the L output, inductor output, and this is the capacitor output. So dotted line. Okay. Okay. So for 0 to A, this inductor will start charging. Okay. For A to B, inductor will discharge. B to C, inductor will charge. For C to D, inductor will discharge. So this process will continue. What happens? Capacitor will come into its action only when inductor discharge. So for 0 to A, inductor doesn't have any operation, so it will start here. Only when this inductor discharge, this capacitor will start charging. So again this will go like this. Okay. So by repeatedly following this process, you will get a pure DC signal. So operation of this choke filter or LC filter, or next we will be seeing RC filter, is same. So RC is capacitor and resistor, but there are two capacitors, C1, C2 are, this is input and this is output. So again when rectified output, that is given as an input here for the filter, what happens is so I'll make it big, 0 A B C D E F. Okay. So what happens when 0 to A is given, this capacitor will start charging, C1 will charge. So that time R and C2 will have no action. So now A to B for 0 to A. So now for A to B, the C1 will discharge to accept the AB signal, and it has to discharge OA signal. So C1 will discharge, this discharged signal will be accepted by R. Here we will be considering only capacitor and inductor, because that's actually charging and discharging. So this discharging, when C1 discharges, this capacitor will charge. For next signal, C1 will charge and C2 will discharge, and this process goes. Now C1 discharge and C2 charge. Okay. So I'll explain by plotting. This is V and this is time. I'll make it fast. Okay. So 0 to A, B, C, D, E, F and G. Okay. So this is C1 output, C2 output. So 0 to A, yes, capacitor C1 will start charging. From A to B, capacitor will discharge. So charge, discharge, charge, discharge. Okay. C2 will come into action only this capacitor discharges, it will start charging. Capacitor C1, when it discharges only, C2 will charge, so it will charge. Now capacitor C1 is charging, that time capacitor C2 will discharge. Then next C1 is discharging, that time capacitor will charge. So this will be like this. So this is the final output. Again multiple process will takes place. Repeating this process, you will get a pure DC signal. Okay. This is how filter actually converts the pulsated DC, which has unwanted AC signal in it, into completely pure DC signal. So These are rest three types of filter, just charging, discharging, when it will charge, when it will discharge. That's what we have to consider here in the filter circuit. Hope everyone understood. If you have any doubt, please let me know. Thank you for watching the video. Like and subscribe the video.